concavity is talking about what's happening with acceleration. So it's the second derivative. You're concave up if the second derivative is greater than 0. Okay, so what that means is that the slopes are going up. They're increasing. It doesn't tell you whether the slopes are negative or positive, but it tells you what's happening with the slopes. Like if you're talking about with a car, if you have positive acceleration, that means your velocity is increasing. Like your velocity is increasing, going faster and faster. Okay. Concave down would just be the opposite, right? The second derivative is less than 0. So what we need to do is first find the second derivative. So it's 30x to the fourth plus 4x to the third minus 5. That's the first derivative. So here's the second derivative. And the derivative of -5 is just 0. Set the second derivative equal to 0, just like what we used to do with critical points, except what we're finding here is potential inflection points is what they're called. Places, everything we solve for here is going to tell us all the possible locations where we switch concavity. So those are potential inflection points. If you actually do switch concavity, then you can formally identify as an inflection point. But to solve, we just factor out a 12x squared, and we're left with 10x plus 1. And then to finish solving, we get x equals -1/10 and x equals 0. Those are potential places to change concavity. So here's x equals 0, here's x equals -1/10. So we want to test a value in between those two. So let's try the second derivative at -1/20. And the reason why we're doing this is because we want to see where is the second derivative greater than 0 to find out where it's concave up. If we plug in -1/20 into the second derivative and we get a positive value, then we're concave up. But look, this is always going to be positive because you're squaring every value. And then 10 times -1/20 makes -1/2. -1/2 plus 1 is positive. So it's concave up between -1/10 and 0. Let's try something to the right of x equals 0. Let's try 1 into the second derivative. And this is positive. This is going to be positive. So positive times a positive makes a positive. It's also concave up over here. And now trying something to the left of -1/10. Let's try x equals -1. If you plug that in, you get -10 plus 1 makes -9. So positive times negative makes a negative. It's concave down over here. Now be careful. It's not -1/10 to positive infinity. It's concave up. Our answer is -1/10 to 0 union 0 to infinity. We have to exclude 0 because we found out that at x equals 0, the second derivative equals 0. 0 is neither positive nor negative, so you have to exclude 0.